Welcome to MRL. In this learning session, we'll be learning about a quadrilateral known as a parallelogram. A parallelogram is a quadrilateral in which the opposite sides are parallel. In parallelogram ABCD, AB is parallel to DC and AD is parallel to BC. It is a parallelogram. Now the properties of a parallelogram. We will be learning the properties of a parallelogram in terms of sides, in terms of angles and in terms of diagonals. Now let us begin with the sides first. The opposite sides are parallel in a parallelogram. The opposite sides are parallel in a parallelogram. The opposite sides are equal in a parallelogram. That means in the parallelogram ABCD, AB is parallel to DC, AD is parallel to BC, and also in the parallelogram ABCD, AB is equal to DC and AD is equal to BC. That is in terms of sides. Now in terms of angles, the opposite angles in a parallelogram are equal. That means angle A is equal to angle C, angle B is equal to angle D. And also the adjacent angles in a parallelogram are supplementary. That means angle A plus angle B is equal to 180, angle B plus angle C is equal to 180, angle C plus angle D is equal to 180, angle D plus angle A is equal to 180. That is in terms of angles. Now in terms of diagonals, in a parallelogram there are two pairs of opposite vertices or non-adjacent vertices, and therefore there are two diagonals possible. That means we have the diagonal AC and diagonal BD, which are the two diagonals. Now the diagonals in a parallelogram are unequal. Please remember this, that the diagonals in a parallelogram are unequal. The diagonals bisect each other. That means if you take the diagonal AC and diagonal BD, O is the midpoint of AC and BD, that is OA is equal to OC and OB is equal to OD. Therefore the diagonals in a parallelogram bisect each other. Remember that. The diagonals form pairs of congruent triangles. That means these diagonals divide the parallelogram into pairs of congruent triangles. That is, triangle AOB is congruent to triangle COD, triangle AOD is congruent to triangle COB, triangle ACD is congruent to triangle CDB, and so on. Therefore, the diagonals divide the parallelogram into pairs of congruent triangles. Remember that. Now we will be learning the different properties and prove them as different theorems in parallelogram. In this theorem we have to prove that in a parallelogram opposite sides are equal. That means we are given a parallelogram ABCD in which AB is parallel to DC and AD is parallel to BC. We have to prove that opposite sides are equal. That is, AB is equal to DC and AD is equal to BC. Now to prove that, let us join AC. Let us join AC. When we join AC, we get two triangles, that is triangle ABC and triangle CDA. Now in triangle ABC and triangle CDA, angle 1 is equal to angle 2 because AB is parallel to DC, AC is the transversal, therefore interior alternate angles are equal, therefore angle 1 is equal to angle 2. So also angle 3 is equal to angle 4 because AD is parallel to BC, AC is the transversal, interior alternate angles are equal, therefore angle 3 is equal to angle 4. And AC is the common side between the two triangles. Therefore, by angle side angle congruency criteria, the triangle ABC and triangle CDA are congruent. If two triangles are congruent, then the corresponding sides are equal. Therefore, AB is equal to DC and AD is equal to BC, and that is the proof of this theorem. Therefore, remember, in a parallelogram opposite sides are equal, and that is the proof of the theorem. In the next theorem, we will be learning about parallelogram, that is, in a parallelogram, opposite angles are equal. We have to prove that in a parallelogram, opposite angles are equal. That means we are given a parallelogram ABCD in which AB is parallel to DC and AD is parallel to BC. Now we have to prove that the opposite angles are equal. That is, angle A is equal to angle C and angle B is equal to angle D. Now to prove this theorem, let us draw the diagonal BD. When we draw the diagonal BD, the parallelogram ABCD is divided into two triangles, and in these two triangles we find that angle 1 is equal to angle 2. they are interior alternate angles, because AB is parallel to DC, BD is the transversal, therefore angle 1 is equal to angle 2, and so also angle 3 is equal to angle 4, because AD is parallel to BC, again BD is the transversal, therefore angle 3 angle 4 are interior alternate angles and they are equal. Therefore in the triangle ABD and CBD, we find that the angle 3 and angle 4 are equal, angle 1 is equal to angle 2, BD is a common side, therefore by angle side angle congruency criteria, the two triangles ABD and triangle CBD are congruent. When the two triangles are congruent, then the corresponding angles are equal, and therefore angle A is equal to angle C. So that is the first proof, that is we have proved that angle A is equal to angle C. Now join diagonal AC. By joining diagonal AC, we can prove that on similar lines that angle B is equal to angle D, and that is how in a parallelogram the opposite angles are equal, and that is the proof of this theorem. Please learn this theorem and remember the method of proving it. The now next theorem is in a parallelogram a diagonal divides it into two congruent triangles. If we draw a diagonal AC in a parallelogram, it divides it into two congruent triangles. A very simple theorem again here. We are given a parallelogram ABCD and AC is the diagonal. Now we have to prove that triangle ABC and triangle CDA are congruent. Now the proof is a very simple proof. Now we know that AB is parallel to DC, angle 1 is equal to angle 2 because of their interior alternate angles, because AB is parallel to DC, AC is the transversal, for interior alternate angles are equal, and same way angle 3 is equal to angle 4 for the same reason that AD is parallel to BC, AC is the transversal, interior alternate angles are equal. Now in triangle ABC and triangle CDA, we have angle 1 is equal to angle 2, angle 3 is equal to angle 4, and AC is common to both the triangles. Therefore by angle side angle congruency criteria, the two triangles are congruent. So that is how we prove that in a parallelogram a diagonal divides the parallelogram into two congruent triangles. Remember that. Now the next important theorem is, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. This is a very important theorem. See, we are given a quadrilateral here, that is ABCD is a quadrilateral, and each pair of opposite sides of a quadrilateral is equal. That means AB is equal to DC and AD is equal to BC. Now we have to prove that ABCD is a parallelogram. So what is given to us is a quadrilateral. Please remember this. ABCD is a quadrilateral. In the quadrilateral, AB and DC are equal, AD and BC are equal. Now we have to prove that this quadrilateral ABCD is a parallelogram. Rather, we are proving that in a quadrilateral, if each pair of opposite sides are equal, then it becomes a parallelogram. Now for proof, let us join AC. AC is the diagonal. Join AC, which is the diagonal. Now consider the two triangles here, triangle ABC and triangle CDA. We know that AD is equal to BC, which is given to us, and AB is equal to DC, which is given to us. AC is by construction, it is a common side to both the triangles. Therefore, by triple S congruency criteria, triangle ABC and triangle CDA are congruent, and therefore remember this, if they are congruent, then the corresponding angles are equal. Please remember this, the corresponding angles are equal. That means we have angle 1 is equal to angle 2, angle 3 is equal to angle 4. That means if angle 1 is equal to angle 2 here, alternate interior angles are equal. That means AB is parallel to DC. If angle 3 is equal to angle 4, again alternate interior angles are equal. That means BC is parallel to AD. So if the opposite sides are parallel in a quadrilateral, it becomes a parallelogram, and that is how we prove that in a quadrilateral, if opposite sides are equal, then the quadrilateral becomes a parallelogram. Please remember this theorem. Now coming to the next important theorem, that is, if each pair of opposite angles of a quadrilateral is equal, then it is a parallelogram. Now what is the meaning of this? We are given a quadrilateral ABCD, and if the opposite angles of this quadrilateral are equal, that is angle A is equal to angle C, angle B is equal to angle D, and then we have to prove that ABCD, which is a quadrilateral, becomes a parallelogram. So let us understand this. Now what is given to us? That ABCD is a quadrilateral, angle A is equal to angle C, angle B is equal to angle D. Now we have to prove that ABCD is a parallelogram. Let us assume that angle A and angle C are equal to x and angle B and angle D are equal to y. Now when I add xx and yy, it becomes 2x plus 2y. So 2x plus 2y is equal to what is called 360 degrees, because the sum of the interior angles of a quadrilateral is 360 degrees. Therefore 2x plus 2y is equal to 360, and rather x plus y is equal to 180 degrees. Now we have shown that here x plus y is 180 and BC is the transversal, the co-interior angles are supplementary, and therefore AB is parallel to DC. And for the same reason, x plus y is equal to 180 here, AB is the transversal, AD is parallel to BC. So we have proved that AB is parallel to DC, AD is parallel to BC, the opposite sides are parallel in this quadrilateral, and therefore ABCD is a parallelogram. Therefore remember, in a quadrilateral, if opposite angles are equal, then the quadrilateral becomes a parallelogram. A very important proof and also the theorem. Now the next important theorem is, if the diagonals of a quadrilateral bisect each other, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. That means we are given a quadrilateral ABCD and the diagonals are here BC and BD. And these diagonals bisect each other. That means O is the midpoint of AC and BD, rather OA is equal to OC and OB is equal to OD. Now we have to prove that this quadrilateral with the given conditions becomes a parallelogram. So let us see the proof of this. Now in triangle AOB and triangle COD, angle AOB is equal to angle COD, vertically opposite angles, and OB, that is OB is equal to OB is equal to OD, because we have been given that OB is equal to OD, and by SAS congruence, and also OA is equal to OC, because the diagonals bisect each other here. So we know that OB is equal to OD and OC is equal to OA. The angle AOB is equal to angle COD. That means we have proved that these two triangles are congruent. That is, triangle AOB is congruent to triangle COD by side angle side congruency criteria. Side angle side congruency criteria. That means if the two triangles are congruent, then the corresponding angles are equal. Therefore angle 1 is equal to angle 2, angle 3 is equal to angle 4. If angle 1 is equal to angle 2, it means that the interior alternate angles of this quadrilateral are equal, and AC is the transversal, and therefore AB is parallel to DC. AB is parallel to DC. So also angle 3 is equal to angle 4, again interior alternate angles are equal. BD is the transversal, and therefore AB is parallel to DC. So we have proved that AB is parallel to DC and AD is parallel to BC, and therefore this quadrilateral is a parallelogram. Therefore remember, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Remember that. Now this is another theorem, and the theorem states that a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Now what does that mean? We are given a quadrilateral ABCD in which AB is parallel to DC and AB is equal to DC, and we have to prove that ABCD is a parallelogram. So let us understand this. Given ABCD is a quadrilateral, AB is equal to DC and AB is parallel to DC. Now we have to prove that ABCD quadrilateral is a parallelogram. For that, let us do a construction join AC. Now in triangle ABC and triangle CDA, ABC and triangle CDA, we have AB is equal to DC, which is given to us, and we are also given that AB is parallel to DC. If AB is parallel to DC and AC is the transversal, therefore angle 1 is equal to angle 2, that is interior alternate angles are equal, and also AC is common to both the triangles. Therefore in triangle ABC and triangle CDA, we have got AB is equal to DC, and angle 2 and angle 1 are equal, and AC is common, and therefore by side angle side congruency criteria, these two triangles are congruent, and if the two triangles are congruent, the corresponding angles are equal. That means and corresponding sides are also equal. Therefore AD is equal to BC and angle 3 is equal to angle 4. Now alternate interior angles are equal. Here again angle 3 is equal to angle 4. AC is the transversal, therefore AD is parallel to BC, and therefore now we have AB is parallel to DC, which is given to us, AD is parallel to BC, which we have proved, and therefore in this quadrilateral the opposite sides are parallel, and therefore it is a parallelogram. Therefore remember, a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. So that is a very important theorem again. So these are the various theorems of parallelogram. So learn these theorems, learn the properties of a parallelogram. Very useful information about parallelograms. Okay, note them in a book and keep it as a reference for your future use. Thank you.